In this video, we're putting everything together that we've talked about as far as congruent figures and drawing some conclusions from that and doing some proofs with that. And our activity starts out by asking us to draw a triangle on a piece of folded paper and then cut the triangle out, which you see that I'm doing now, so that we can talk about the parts of the two triangles that I'm now forming. And my scissors skills are not very good right now. Oh. So there we go, two triangles. And since they're congruent, and I call this A, B, C, here we go, and D, F, and E, it's saying place the triangles next to each other, and since the triangles are congruent, there must be a sequence of rigid motions that maps one to the other. Describe the sequence of rigid motions. Well, if I'm looking at these two triangles, I might say it was a translation. So since the same sequence of rigid motions maps the triangles to each other, then it maps the parts of them to each other. So AB will map to DE, angle A will map to angle D, segment BC will map to segment EF, angle B maps to angle E, segment AC maps to DF, and angle C maps to angle F. In part D, they're asking us, what does step C tell us about the corresponding parts of the two triangles? And why is this true? Step C is telling me that the corresponding parts of the congruent triangles are also congruent. And the reason why is because of the definition of congruent. Since the definition of congruent, the definition that we have been using, says if they are mapped to each other, using a rigid motion, then they're congruent. So let's take that and push that further. In the previous statement here, we were talking about how one segment is mapping onto another. Now I know from what we just wrote down in the last example, we know that these things are congruent. So segment AB is congruent to segment DE. Segment BC is congruent to segment EF. And segment AC is congruent to segment DF. It's asking for 6, and in a triangle, there's 3 pairs of sides, or in 2 triangles. There's going to be 3 pairs of sides and 3 pairs of angles. So I know angle A is congruent to angle D, angle B congruent to angle E, and angle C congruent to angle F. They're asking us if that applies to other kinds of figures. For example, here, if I know that these quadrilaterals are congruent, can I make any conclusions about the corresponding parts? Yes. Again, because of the definition of congruent. We know all of their corresponding parts are congruent. And by parts, let me be more specific, all of their corresponding sides and angles are congruent. So in example 1, they're asking us to use that. In part A, which they've done for you, I'll talk you through it, they're asking to find the length of DE. So I look at DE, it's here, and I would advise, look at this, what we call congruence statement. This is our congruence statement. So notice where DE is. It's the first 2 letters of triangle DE. Okay, well, it's going to correspond to the first 2 letters of the other triangle. That's AB. Well, I know that the length of AB is 2.6, so there it is. They concluded that DE is 2.6. Let's use the same line of reasoning for angle B. So they're asking us to find the angle that corresponds to angle B. Once again, since I know that these 2 triangles are congruent, and I know that corresponding parts of congruent figures are congruent, this B corresponds to this E. And in the diagram, I know that angle E is 65. So that means that angle B is also 65. Let me backtrack a little. I said it, but I didn't make a point of this is a property that you can use. Maybe you want to highlight it. In this reflect question, you want to be really, really careful. They tell us in the instructions that the triangles are congruent, but they don't specifically give us the congruence statement. They're asking us, can I conclude that JK is congruent to QR? Well, it sure looks like it is, but it sure looks like it could possibly be congruent to PR. So I'm going to say not necessarily. The congruence statement wasn't given. And JK could be congruent to PR. So you want to be careful about assumptions that you make. Pause the video and work through the your turn below. In example 2, we're taking what we just did in example 1 and pushing it to the next level with some equation solving. Before I get into that, though, notice these properties of congruence. These names should look familiar: reflexive, symmetric, and transitive. Remember, the reflexive property of equality is that a number is equal to itself. So like 3 equals 3. Well, now we're applying that to congruence. So we're saying that a segment is congruent to itself. For example, segment AB is congruent to segment AB. And you see the examples for the other two properties as well. Symmetric property allows me to take a congruent statement and flip it around. Transitive property allows me to take two congruences to the same thing, means that they're congruent to each other. Okay, so in example 2, you notice that they're asking for the length of AB. Well, AB is expressed as 3x plus 8. I know that AB will be congruent to DE, so that's why they set up the equation 3x plus 5 equal to 5x. And then they solve the equation, just like you did last year in Algebra 1. Once they solve for x, however, realize you're not done until you've answered the question. The question is asking you for the length of AB. So that's why they took the value of x, and plugged it in for x in the length of AB. And they found that it's 20 inches. In part B, again, since we know that these triangles are congruent, what angle is going to be congruent to angle D? Well, angle D is the first letter of this triangle, so I know it's got to be angle A. Therefore, the measure of angle A will equal the measure of angle D. So write an equation, and we have to kind of flip back and forth between our pages. 5y plus something. Well, where do I see a 5y? 5y plus 11 here is the measure of angle A. Okay, so I'm taking that and substituting it in. So it's 5y plus 11 equals something plus 2. Well, that's got to have to do with the angle D. So what is angle D in the diagram? Angle D in the diagram is 6y plus 2. And then we solve the equation. Notice that they're telling us subtract 5y from both sides. So when I subtract 5y here and subtract 5y here, that'll give me 1y, or just y. Then they're saying subtract 2 from both sides. So when I subtract 2 here and subtract 2 there, I get that 9 equals y. So we take that value of y and substitute it in for y here, and then evaluate it. 6 times 9 is 54, plus 2 is 56. Let's do one more example like that. In number 6, I'm asked for the length of LM. Notice here I'm told that LM is equal to GH. Okay, so LM, the length of LM is equal to the length of GH. Well, the length of LM is 6x minus 13. So that's going to equal the length of GH. That's the 4x plus 3. Okay, so this is, if I wanted to write a reason for each statement to kind of get me ready for example 3, this would be the definition of congruent. This would be, this would be substitution. I'm going to subtract 4x from both sides to get 2x minus 13 equals 3. That's subtraction. I'm going to add 13 to both sides to get 2x equals 16. That's addition property. And finally, x equals 8 by the division property. But the problem wasn't asking me for the value of x. The problem was asking me for the length of LM. So here's LM. I take 6 and plug in 8 for x, and then minus 13. So that's 48 minus 13, which is 35. In example 3, you see we're starting to get into formal proofs. So they've done the first one for us. Let's talk through it. I am given that these triangles are congruent. So that's why they start with that. Most of your proofs will start with what you're given. And then I'm going from there to stating that BD is congruent to CD. Because since I'm trying to prove that D is the midpoint of BC, it would be nice if I knew that these segments were equal to each other. or congruent to each other. And the reason why BD is congruent to CD is because they're corresponding parts of congruent figures. That's also known as a definition for congruent figures, so that's why you saw me use that here. And then finally, D is the midpoint of segment BC because of the definition of midpoint. And there's your first formal geometric proof. In part B, they've set up the statements for us. We need to come up with the reasons. So in statement 1, quadrilateral JKLM congruent to quadrilateral NPQR. Always look at your given and look at that. It's right there in the given. I'm also told in the given that angle J is congruent to angle K. So that's my reason for statement 2. But then why is angle K going to be congruent to angle P? Well, let's look at them in the statement. K is the second letter. P is the second letter. So since those figures are congruent and they are corresponding parts of them, I can say corresponding parts of congruent figures are congruent. And then notice how statements 2 and 3 come together to give me statement 4. Angle J is congruent to angle K is congruent to angle P, therefore angle J is congruent to angle P. That's the transitive property of congruence. Once again, that's this property back here. Notice how these two are common. So I take these two congruent statements and smush them down into one. And that's what happened here. We took these two congruent statements, and since they had K in common, I smushed them down into one. Let's do another proof. Okay, so we have statements and reasons. And 99.9% of the time, you start with the given. So that's what we're starting this proof with. Triangle SVT is congruent to triangle SWT. And that's what I'm given. Now, there's plenty of other statements that I can make now based on that. Remember, we talked back here about how when I know that two triangles are congruent, I've got 6 congruent statements that I can make. But I don't want to make all 6 of them. I want to make the one that's going to get me closer to my end game. I'm trying to prove that ST bisects angle VSW. Okay, so what does it mean for ST to bisect angle VSW? Well, here's angle VSW. And if ST bisected it, then it'd be convenient if I could say that this angle is congruent to this angle. So that's VST, notice letter 2, letter 1, letter 3, congruent to angle WST, letter 2, letter 1, letter 3. So I can make that statement. Let's go ahead and do that. VST, angle VST, is congruent to angle WST. And once again, my reason is that corresponding parts of congruent figures are congruent. And now I can close my proof out. I can say that ST bisects angle VSW